Hmm. Okay.
Good morning.
Good morning. Sorry, I'm
Also,
still
um,
eating.
it's
What you
okay.
got?
The extra credit packets, there wasn't an area to upload that.
I just got that loaded a few minutes ago. So if you check back, it'll be there.
Okay, does it still count after
Yeah,
class?
yeah,
Okay.
absolutely. Absolutely. Don't stress about it. That's what I was doing just a minute ago.
Okay, thank you.
So yeah, I was gonna tell y'all that it'll be there this afternoon or after class. How are you, Miss Keeling?
I'm doing well. How are you doing?
Good, thank you. I will work on a list today and make sure you've got everything.
Thank you so much. That would be
You,
great.
you're welcome. Good job watching videos and getting caught up.
Also, you want us to start taking notes now, right?
Well, you're taking notes in class will help you. The main thing is that you will be putting some notes at the top of your homework. So if you want to do it during class and for the homework, you can. If you just want to do for the homework, that's all I'm going to be looking for.
Okay.
And so, but if it helps you just to kind of jot down some ideas as we go, you know, that's totally up to you if that helps you. I'll wait on everybody else to get logged in. I'll finish eating, so I'm not eating while we're having class. Okay, so it looks like we've got everybody but April. Hopefully she will join in a few moments. And so, just so you guys know, I have just added the place to upload the homework, the extra credit work. So if you haven't uploaded that, don't stress. It is there now, so you can upload after class or just sometime later today. So that is now there. And then, so what we're going to start off with today is doing our Chapter 3 review. We had a Chapter 3 review for homework. We'll kind of go through real quick. We'll scoot through the chapter one more time just to kind of look at the highlights. And then I'll be emailing you the Chapter 3 test. And we'll take a look at it as a class to make sure that y'all don't have any questions about what the test is asking. Here comes April. So what we will do is we'll go ahead and start out with going through the Chapter 3 review and seeing if there's any questions. So like I said, with the review, you were able to go back and check your work. So hopefully you did that. Hopefully you've already checked it and you know what you had trouble with. And so section 3.1, dealing with lines and angles. Section 3.2 was proofs and perpendicular lines. 3.3, parallel lines and transversals. 3.4 was proving parallel lines. And then 3.5 was using properties of parallel lines. 3.6, parallel lines in the coordinate plane. And then 3.7, perpendicular lines in the coordinate plane. So let's go ahead and take a look at that Chapter 3 review. Any questions from section 3.1 dealing with lines and angles? Okay, so that was numbers 1 through 5. Okay, we skipped, well, that was an odd number. Okay, so then moving on to 3.3, parallel lines and transversals. That would have been number 9. Any questions on that? All right, 3.4, proving that lines are parallel. We didn't have anything from that. 3.5, using properties of parallel lines. That would have been numbers 13 and 15. Any questions on that? Awesome. Moving along. 3.6, parallel lines in the coordinate plane. So this was where we were using our slope formula to determine if lines were parallel. So 17 and 19. Any questions there?
On 17.
Okay. So let me pull up my screen real quick. So, my husband and child just got home from getting COVID tested, so I'll have to pause in just a minute to find out what the result is. My daughter came downstairs. She's had a little bit of a congestion issue, and we've been thinking it's allergy related. And then she came down this morning and said, I don't think I can smell anything. We were like, well, that's kind of a problem. So he got to go take her to get COVID tested. I'm surprised they're back already so soon. I think that was them. I just heard pulling the driveway. So just to give y'all a heads up, if I tell y'all to hang on a minute, I'm getting the results to find out if we all get to be in quarantine or what. So anyway, let me get my screen pulled open real good so I can see everybody. All right, so we've got our screen open. Number 17, is that what you said, Alec?
Yes, ma'am.
Okay, so remember one of two things. If we have a graph and our points on our graph are at perfect places on the graph, at perfect intersections, we can do one of two things. We can either use our slope formula, and to do that, number one is to determine point coordinates. And then two is to use slope formula. Okay, hang on just a minute. No news yet. She has to go back at 10. So anyway, I guess we'll see. Alrighty, so like I said, the first thing we have to do is to, you can determine the coordinates of each point and then use the slope formula, okay? Or I can count my slope and I can look to see when I start, I typically like to start at the one that's highest. You can start at the one that's lowest and go up. It's totally up to you, so we'll go ahead and do that. So if we're going from A to B, I look and I go 1, 2, I've gone 2 up, so that means it's a positive 2. So remember, my slope is going to be rise over run, so that means I have 2 in my numerator, and then I go 1, 2, 3, 4 to the right. So again, that's positive. So I have 2 over 4, which reduces to 1/2. Okay, I can do the same thing with C and D. I go up 1, so that's a positive 1, and right 1, 2, positive 2. So the slope of that line again is 1/2. I know that my two slopes are the same, so they are parallel.
I don't know what I did different, but I got 2 over 5.
Okay, so evidently you just either, did you use the slope formula? Did you do the m is equal to y2 minus y1 over x2 minus x1, or did you count it?
I did do that.
You used the formula?
Yes, ma'am.
Okay, so you'll probably, there's a calculation error somewhere right there. So probably if you just look back at it, you'll see where you made your mistake. All right, any questions on 19? Okay, moving along to 3-7, we have numbers 21 and 23. We were determining whether the lines of P1 and P2 are perpendicular. Any questions on 21 and 23? All righty, and I guess that was it for the chapter review. Oh, and then we went to chapter test, and we did 1 through 5 odds. Any questions there? And then we had 9 through 15 odds. Any questions there?
On number 13.
Number 13?
Yes, ma'am.
Okay, so the line perpendicular to y equals negative 2x plus 4 and passes through the point negative 1, 2. All right, I'm going to come down here at the bottom. So the first thing is I've got to think about what is the slope of a perpendicular line. If this line is -2, then what do I know the slope of a perpendicular will be? The
2.
negative reciprocal would be 1/2. Okay? Because the first one started out negative, so my negative reciprocal has to be positive. My first one is 2/1, so 1/2 is the reciprocal. So I know that for my perpendicular line, I'm going to have the slope is 1/2. Now what I've got to do is I use that point that they've given me, that -1, 2. So I use y equals mx plus b. I'm going to plug in 2 for y because my point is -1, 2. So I'm plugging in 2 for y. I've got 1/2 for my slope. So 1/2 x. No, not x. I'm going to plug in -1 for x plus b. Okay? So first I found my slope by looking at the negative reciprocal. Then I plugged in -1 for x in my equation and 2 for y in my equation. So now I'm going to solve this to find b. Okay, so I have 2. Whoop, where did my 2 go? 2 is equal to -1/2 plus b. I'm going to add 1/2, add 1/2. So I'm going to end up with, if I have, this is where I have to think about, realistically, you could say 2.5 or 2.5 if you want to do that. So you've got 2.5 is equal to b. So b equals 2.5, or you could have it as 2.5. You could have it as an improper fraction, 5/2, because when we add 1/2 and 2, remember that's the same as 2/1. When I add fractions, I have to have common denominators, so I'm going to have a denominator of 2, so that means I had to multiply this by 2 and this by 2. So that's going to be 4, so it ends up being 5/2, okay? So you could either use the decimal or you could use the fraction of 5/2. So now we found the value of b. I'm going to go ahead and keep it as a fraction. So I'm going to have y is equal to 1/2 x plus 5/2. So the first thing we did is found the negative reciprocal. Then we plugged in the values of x and y to our slope-intercept formula. We were able to solve for b. Once we had b, then we could plug everything in to that original slope-intercept equation, because remember, we have to have the slope and we have to have the value of b. Does that help?
Yes, ma'am.
Awesome. All right, any other questions on that chapter test? All right, so in looking at the chapter test, looking at the review and everything, let's flip back for just a minute. We're going to do a quick review through the chapters so we can kind of look and see, hey, what are some things that you might want to go back and study before the test and make sure that you know. So starting on page 129. Got a good ways to go. Nope, too far. All right, starting on 129. If I can get there. Lines and angles. Okay, so definition of parallel lines: coplanar and don't intersect. Okay, skew lines are the ones that do not intersect and are not coplanar. Okay, so skew lines and parallel lines are similar in that they do not intersect. They are different in that Parallel are coplanar, skew are not coplanar. Okay, we talked about our symbol to be able to identify parallel with our two little lines together that look like two L's. We talked about being able, you know, we looked at our cube as different planes. We talked about lines that were parallel, lines that were skew. We had the parallel postulate and the perpendicular postulate that basically said if I've got one line and a point that is parallel, that is not on that line, there's exactly one parallel line that could run through it that will be parallel to the line that's already given, and you could draw one perpendicular using the point that's given and the line that's given. Moving on, we talked about transversals, and we talked about how a transversal cuts through lines, okay? Now notice when we talked about the positions of these lines, we only talked about their position in relation to where they lie. So corresponding angles, remember corresponding angle is by corresponding position. Change my color so it'll stand, or let's do a highlighter. Come on, give me a different color. Let's go pink. Okay, corresponding angles, corresponding position, okay? And then we look at alternate exterior. Exterior, remember they're outside the lines, but they are on opposite sides of the transversal. Outside my two lines, opposite sides of the transversal. Alternate exterior, I'm sorry, alternate interior, same situation where they have a relationship to the lines in the transversal, but interior, they lie between the two lines, but they're still on opposite sides of the transversal. Consecutive interior, they lie between the two lines, but they're on the same side as the transversal. So on the test, I believe that there will be a diagram with these same types of situations, and you're going to have to tell the relationship between the angles. Are they corresponding? Are they alternate exterior, alternate interior, consecutive interior? Okay. Now remember, in these types of relationships, we cannot determine all equivalent angles, just because I can't say that angle 1 and angle 5 are equivalent angles because my lines are not parallel. Remember, I can only tell equivalent angles if I'm dealing with parallel lines. So we'll get to that in just a minute. All right, all we talked about was relationship based on position there. Then moving on to 3-2, proof and perpendicular lines. This is where we looked at a flow proof. We're not going to worry about that. What we are going to worry about is the theorems here. If two lines, whoop, my broadcasting stopped. Hang on just a second. Let me see if it'll go back up. I don't know what happened. Come on. Oh my goodness. I think I've decided I'm going to have to sit down and take time to break this book up into chapters. I thought it was always just going to pick up where I left off, but evidently not. All right. Okay, so theorem 3.1, if two lines intersect to form a linear pair of congruent angles. So remember, linear pair means they go together to make a line. They are congruent, then they form a perpendicular line. If two sides of two adjacent acute angles are perpendicular, then the angles are complementary. Complementary means they add together to make 90 degrees. If two lines are perpendicular, then they intersect to form four right angles. So that's where we get that we know that when two angles are perpendicular, we have four right angles. We're going to scoot on beyond that. 3.3, parallel lines and transversals. Okay, so this is where we talked about how if I have a transversal that intersects parallel lines. Earlier, we just looked at a transversal intersecting two lines that were not parallel. And all we could tell there were angle relationships. Now, when I have parallel lines and transversals, not only can I tell angle relationships, but I can also determine angle measurements. Because when the transversal cuts one line, it is creating angles that are going to be exactly the same as when it intersects the second line. Okay, so it says if corresponding angles postulate. So here we've got the corresponding angles postulate. We have alternate interior angles, consecutive interior angles, alternate exterior, and then perpendicular transversal. So the main thing to know about these is that the corresponding angles postulate says that if they are corresponding angles and it's parallel lines cut by transversal, then they are congruent. Alternate interior angles. Alternate interior angles are congruent if it's a transversal and two parallel lines. Consecutive interior angles, this is the one that's different. Okay, so most of them we've looked at and said, oh, we can tell that these are congruent because they're alternate interior, alternate exterior, because they're vertical angles or because they're corresponding. All of those we can tell that they're congruent. But here, this is the one that's kind of the outlier. It's a little different. And it says if two parallel lines are cut by transversal, then the pairs of consecutive interior angles are supplementary. That means I can add angle 1 to angle 2. The measure of angle 1 plus the measure of angle 2 equals 180 degrees. Okay, so that means I've got to add them together. I said the measure of angle 1 and angle 2. It just depends on what your diagram shows and what the measures of angles are. This one gave us 5 and 6, so that's all they did was add the two together to equal 180. You need to know this. Hint, hint. You need to know this. Okay. Moving along. 3.4, proving parallel line. Proving lines are parallel. So basically, earlier we said that, hey, we can prove that angles are congruent based on parallel lines, and now we're using our angles to prove that the lines are parallel. So we're just doing the converse here. So the main thing to know here is I've got the same situation, corresponding angles, but it's called the corresponding angles converse because I'm using the angles to prove the lines are parallel. Okay, so corresponding angles are corresponding. Yes, corresponding angles will just be using the lines and the angle placement to determine that the angles are congruent. Here, I'm telling that the lines are parallel. Okay, same thing with alternate interior angles converse. I'm using the angles to tell the lines are parallel. Consecutive interior angles converse, again, this is the same thing. So if the interior angles are supplementary, so if I can add the two angles together and they equal 180, then the lines are parallel. Alternate exterior angles converse, if they're alternate exterior angles, if they're congruent, then the lines are parallel. Okay, so the converse is where I use the angles to prove parallel lines. The regular statements are where I'm using my rules about parallel lines to prove that the angles are congruent. Then, properties of parallel lines. So again here, knowing those properties that we've already learned, we had a few more theorems that we picked up here, and that was if two lines are parallel to the same line, then they're parallel to each other. And if two lines are perpendicular to the same line, then they're perpendicular to each other. Kind of using that transversal that we've looked at, that if one is equal to another, and then the other one is equal to yet another one, then, or congruent to it, then they're congruent to each other. All right, so this is where it got a little different, and this was parallel lines in the coordinate plane. This is where we had to stop and use our slope formula, which is y2 minus y1 over x2 minus x1. Remember, rise over run. Rise tells us up and down is my y-axis. That's how I can remember that the y goes in the top. X is side to side, so that's run. Okay, typically when we run, we're running like in a side-to-side direction. We're not running like up a wall. So we run side to side, so that's going to be in the denominator. I can find 2 points, plug them into the formula, and solve. And so, Millie, no. So we talked about being able to find the slope in a minute ago in the exercise. We talked about we could either use the slope formula and plug in our numbers, but we do want to make sure that our calculations are correct, so you may want to glance back over it. When you get a no, but yet you're looking at the picture and you go, hey, but these look perpendicular, parallel, plug them back in and check, okay? Also, we talked about how you can count them. You can start at one point and go down in whatever direction, or you can go up in the other direction. Slopes of parallel lines, Millie, no. Hang on just a minute. Millie, come here. Come here. Hey. No, ma'am. Oh, there's the yard people outside. Not my yard, I wish. But okay. So if the slopes are the same, lines are parallel. Plain and simple. Writing equations of parallel lines. So again, if I'm writing an equation of a parallel line, I already know my slope. And if they tell me it has to run through a certain point, that is where I will plug the values of my point in and solve for b. Then I can use my y equals mx plus b. I know my slope. I have solved for b, so I can plug it into my equation. Okay? So that's what we did with writing an equation of a parallel line. We're going to do the same thing for perpendicular lines, except for our slope, we have to do the negative reciprocal. That's the only different thing from using a point to write an equation of a parallel line and using a point to find the equation of a perpendicular line. In one, the slope will be the same, and the other one, the perpendicular, will be the negative reciprocal. I'm going to go through the same process of plugging in the values for x and y to solve for b first. Then I can write my equation. And that is it. Okay, and remember, if we're using the coordinate plane or using the slope formula, that is where we look to see, do I have negative reciprocals? One of the ways they describe it is that the product of the two is equal to one. And so, I'm sorry, -1. The product has to be -1 because remember, when we multiply them together, we've got one negative and one positive, so that's going to give me a negative solution, okay? So you can either look at it that way, that you can multiply them together to equal -1, or you can just remember negative reciprocals, okay? So any questions about chapter 3? Anything that you're still having trouble with and you're just not sure about?
Didn't we have a homework on page 175 and 176?
Probably. Yeah, so we'll go back to that in just a minute. Any questions on the chapter review? Okay, so then let's go back and scoot back for just a minute to 175 and 176 and see if there's questions there. I think that was assigned before we started our new process, so we'll need to go over those answers. That's 163. Okay, so on 175, we had 8 through 24 evens. So I'm going to read those out real quick. So starting with number 8, the direction said, are the lines perpendicular? Number 8 is no, 10 is yes, 12 is yes. Any questions on those? Okay, the next section says lines J and N are
Wait, yes,
perpendicular.
I do have one question.
Okay,
On 8.
okay. So notice I've got 2/3 and 3/2. Why are these not perpendicular?
Because one is not a negative?
One is not a negative. Very good. They are reciprocals, but they're not negative reciprocals.
Okay, and what were 10 and 12?
My screen keeps going out. 10 is yes and 12 is yes.
Okay, thank you.
Mm-hmm.
Could you work out 14 and 16? No,
Okay.
14 and 18, sorry.
Okay, sure. Let me get my screen back up. I don't know why it keeps jumping out. If we're lucky, it's gonna, no, because Notability should, okay. Okay, so now it says lines J and N are perpendicular. The slope of J is given. What is the slope of N? Okay, so in number 13, it would be -1/2. No, wrong numbers, we're doing evens. Okay, so 14 is -1/5.
Could you work that out?
Okay, well, there's really nothing to work out here because if I'm given 5/1 and it's positive, then that means for the negative reciprocal, I've got to make it a negative and I've got to flip it.
I get it now, thank you.
Huh?
I said I get it now.
Okay, same thing with number 16. It's -7, so that's the same as -7/1. So to do the negative reciprocal means it has to become positive and then it flips. Number 18, I have a +1/5, so I have to make it negative and flip it to 5/1, which is the same as just -5. 20, I have -4/3, so that means it's going to become positive, and I flip it. Okay, so it will be 3/4 on number 20. Any other questions on that section? Okay, and then 22 and 24, decide whether the lines are perpendicular. So 22, line AC, let's see, the slope of AC is 3/4. The slope of BD is -3/2. So my slopes are not the same, therefore they are not perpendicular. Okay, so 22, they are not perpendicular. 24, I have line AC, and the slope of AC is -2. And then I have line BD, and the slope is 1/2. So these are perpendicular. Questions about either of those? Awesome. So we had 8 through 24 evens there, and then on the next page, 26 through 36 evens. So let's take a look at 26. It says decide whether lines K1 and K2 are perpendicular, then graph the lines to check your answer. I don't think we talked about that. So as far as the homework goes, if you did not actually do a graph, that's okay. So let's look at number 26. Okay, so if we look at 26, trying to decide if they're perpendicular, I have got -4/5 and 1/5. Those are not negative reciprocals, so they are not perpendicular. Number 28, I've got 1/3 and 3. They are reciprocals, but they are not negative reciprocals, so they are not perpendicular. Any questions on those?
Okay, so with the graphing thing, I got them right on the with the actual with the actual problems, like I got the right answer.
Yeah.
But I'm not sure if I graphed them right at all because it looks kind of strange. So.
Okay, so remember that with graphing, the first thing you would graph is the y-intercept. So your y-intercept, the ordered pair would be 0, -2. Okay, so that means I would graph 0, -2 as my given point. And then using my slope of -4/5 means I would go down 4 and then right 5 or up 4 and left 5. Okay, so you would start at your point that you've graphed and use that slope. Same thing with 1/5 x plus 4. Your ordered pair would be 0, 4. Then you're either going to go up 1, right 5, or down 1, left 5. Okay, so you can go back and kind of check those to see what it was, and then if we need to look at it together, I'm happy to.
That sounds good. Thank you.
You're welcome. All right, then decide whether the lines are perpendicular. So again, in these, they are not in y equals mx plus b form, so I have to put them in y equals mx plus b form. So for number 30, okay, I need to go to y equals mx plus b form. So to do that, I am going to need to add, why does my screen keeps going out? I don't know why it won't stay connected today. Okay, try this again. Okay, so we need to put it in y equals mx plus b form. So that means that I only need y to be left on the left-hand side. So that means I have to add 6x to both sides. So I end up with y is equal to 6x plus 2. Same thing with this next one. I need to add x to each side. So now I have 6y is equal to x plus 12. Except for I've got 6 with y, so I need to divide by 6, which means I have to divide every other term on the other side by 6. So y is equal to 1 over 6 x plus 2. Okay, so the first one, I have y equals 6x plus 2. Then I have y equals 1/6 x plus 2. They are reciprocals, but they are not negative reciprocals, so my lines are not perpendicular.
Miss Jennifer, I got the right answer, but I didn't set it up right.
Okay, so you'll just want to make sure that to ensure that you get the right answer, you have to solve for y. Okay, so I don't know, it's one of those things where if we don't know exactly how you got there, then we can't say it's going to work every single time. So you just want to make sure that in both situations you're putting it in y equals mx plus b form and then comparing your slopes.
Okay.
Okay, so then again for the next one, same thing. I've got 5y plus 3x equals -15. So I'm going to subtract 3x from each side. So I'm going to have 5y is equal to -3x minus 15. Divide every term by 5. So y is equal to -3/5 x minus 3. So there's the first one. The next one, I've got to do the same thing. So I'm going to add 5x to each side. So 3y is equal to 5x minus 33. Divide each term by 3. And so I end up with y is equal to 5/3 x minus 11. So in my first one, I have, -3/5. In my next line, I have 5/3. One is negative, one is positive, so that's a good thing. They are reciprocals, so they are perpendicular. Any questions about 30 or 32?
I kind of just did the equation in my head and then just said yes or no on the piece of paper I did my homework on. Is that okay, or would you like me to work
Well, going forward, I'm going to need to see your work. Okay, so with our new homework process for this one, we hadn't started that yet, so you would be fine. For the new process, I would need to see that work to see why you said yes or no.
All right.
Okay. All righty, so that was it for those pages. And then on the next page, we have 42, 44, 48, and 50.
Did you work out 42?
Wait, hang on. I think we missed 34 and 36.
Oh, yeah, we did. I just jumped right over those, didn't I? Okay, sorry. I looked where I had written on that graph for 34, and I just said, hey, we're done with that. Okay, so again, find the slope of each line, and then we had to decide parallel or perpendicular. Okay, so I'm going to erase this work that's right here so I can see my graph. Again, I'm looking at my lines. Okay, I've got line EF, and then I have line LK. Okay, so the first thing I want to do is I want to look at EF. And so what I'm going to do is I'm going to go ahead and count my slope. And I'm going up 2, so that's positive, and then left 1, 2, 3, 4, 5, 6. So that would be a -6. So my first one is going to be 2 over -6, which is going to be a -3. K to L, I'm going down 1, 2. So I know that's negative. And right 1, 2, 3, 4, 5. So I went right 5, so that's positive. Millie, you need to go upstairs. Hey, go upstairs. Go. Hang on just a minute. Let me get my husband to call her upstairs.
So, how's everybody doing?
I'm great. I mean, if I'm being honest, school, I'm behind. Actually, I'm not, but I don't like it. It's just a matter of passing right now.
I agree.
I know right now this is a difficult format. And so my hope is that with changing kind of what we're doing, it will help you understand better. Unfortunately, it's not going to be something that's quick and fast as far as being able to get your homework done, because probably you're going to be writing a whole lot more down and it's going to take you more time. But ultimately, the goal is for you to understand. And so I hate that part of it, but I need y'all to understand. So I know it stinks.
Does it
I'm right
matter?
there with you though.
Does it matter if I did FE? Like, cause I did EF. But like, would it matter if I did FE?
You tell me, does it matter? When I look at naming that line, could I name it EF or FE? Is it talking about the same line?
Yes, ma'am.
Mm-hmm. Am I going to find the same slope whether I call it EF or FE?
Yes. Ma'am.
Yeah, so it's okay. Okay, so it's just fine. All righty, so we've said that our first one we found the slope was 2 over -6, which simplified to -3. And then our next one, KL or LK, whichever one you want to call it, is going to be -2 over 5. Okay, so we can see here that these are not parallel. Okay, so now we're going to look to see, do we have perpendicular? So I'm going to change my color to do perpendicular. We'll make it a lovely shade of green. So now we're looking at GH. Okay, so again, I'm going to start at the top and go down. 1, 2, 3, 4 down. So that's going to be -4. And then left 1, so that's -1. So -4 over -1, whoop, that's a 4, is equal to 4. Okay, so in number 34, I've got
Yeah.
oh, look what why did I said 2 over -6 equals -3. Y'all gotta tell me when I've done silly stuff. That is not correct, because that would be -1/3. -1/3. Okay. All right, so I've got a negative 1/3 and negative 2/5. So we said that they are not parallel. And then I've got negative 1/3 and 4, not perpendicular, negative 2/5 and 4. So we do not have any perpendicular lines. So no parallels, no perpendiculars. The way we did that was comparing the slopes. Same thing with 36. We're going to do the same thing. I'm going to start with QR or RQ, whichever one you want to call it. And I'm going to go down first from Q, 1, 2, 3, 4, 5, 6. So to get there, I had to go down 6 and right 1, 2, 3, 4, 5, 6, 7. So my first one is going to be negative 6 over 7. Then to do SP, I'll do a different color so it'll stand out a little bit. So SP, I'm going down 1, went too far. I'm going down 1, and so that's a negative 1, and then right 1, which is a positive 1. So I have negative 1 over positive 1, which is a negative 1. And then for my transversal, I'm going from O to P. So I'm going down 1, 2, 3, 4. So that's negative 4. And then left 1, 2, 3, 2, 3. So that's left 3 is negative 3. So I've got negative 4 over negative 3, which would be 4/3. So now we're comparing. I've got negative 6/7. I've got negative 1. And then, what did I mess up there? Then 4/3. Oh, silly me, I did SP, not ST. Good grief. So let's fix that real quick. I should have done ST because I'm doing this line, okay? So S to T goes 1, 2, 3 down, so that's a negative 3. And then 1, 2, 3, 4 right, so that's positive 4, so that's negative 3/4. Okay, so that negative 6/7 is an outlier. I do have a negative 3/4, and then I have a positive 4/3, so that tells me that QR and OP are, no, I said that wrong. That tells me that my blue line, this one, ST, is perpendicular to OP. So these are my perpendicular lines. Okay, so no parallels, but we do have perpendiculars. Any questions about that?
No question, but I do want to tell you. So this entire time, like whenever it asks, like, is it a parallel or not, I would put the perpendicular sign, thinking it was parallel. And I would like cross it out if it was not parallel or something.
Okay.
And like most of my homework is like that, so I'm just letting you know that.
Okay, that's fine. The main thing is I'm glad that you've recognized that mistake. So the main thing that will be different is now when you're checking your homework and you see the different symbols and stuff, you'll be able to make that correction ahead of time. You'll be able to figure that out and then go, and you're not having to wait until we've gone over it in class. Okay.
Okay, I just want to let you know that I meant
That's fine.
parallel.
That's fine. So, I mean, it's the kind of thing where you can, you'll be able to recognize it and make that immediate correction versus having to wait a little while before you figure out what you've done wrong. So again, I'm thinking that'll be a benefit of you checking your homework to be able to know immediately. All right, and then 42, 44, 48, and 50. So 42 and 44, we are, the line given is perpendicular to J at point R. Write the equation of line J. So again, if we know that they are perpendicular, that means I've got a negative reciprocal. So the first thing I have to do is I've got to look at what I'm given. And I need to find the slope of the perpendicular is going to equal the negative reciprocal. So if it starts out as negative 3/4, it's going to become positive 4/3. Again, I have point R, so this is where I'm going to plug it into the equation. Y equals mx plus b. So I'm going to plug in 0 for y, 0 equals, I'm plugging in 4/3 for m, I'm plugging in 8 for x, and I'm solving for b. So I've got 0 equals 4/3 times 8. 4 times 8 is 32. So I've got 32 over 3 is not a perfect, or I can't divide or simplify, plus b. So now I subtract 32 over 3, subtract 32 over 3, and so b is equal to negative 32 over 3. So in this particular one, I know my slope is 4/3. So I have y equals 4/3 x, and then we solved for b and said b was negative 32 over 3. So I'm going to have minus 32 over 3. The first thing I did was find the negative reciprocal of the slope given. Then I solved for b, then I wrote it as the equation. So that's 42. So for 44, my equation would be y equals negative 1/3 x minus 5. Any questions on 44?
I was having some trouble with 44, and I don't really know where I messed up exactly.
Okay, so again, first thing I do is I find my negative reciprocal slope. So we know the slope of the perpendicular is going to be, if we started out with 3, so I know it's going to be negative 1/3. So again, let's see, I'll come up here and use this space. I'll just erase it. So if I know that my slope is negative 1/3, now I've got to use y equals mx plus b. So my value of y that is given, my point is -3, -4. So I know I've got to put -4 in for y. I'm using negative 1/3 for m. I'm using -3 for x, and I'm solving for b, so that stays the same. So I've got -4 is equal to negative 1/3 times -3, negative 1/3 times -3, that's the same as 3 over 1. So when I multiply those, a -1 times a -3 is a +3, and 3 times 1 is 3, so that simplifies to 1. So now I've got 1 plus b. Subtract 1, so -5 is equal to b. So now I know my slope is negative 1/3, my b value is -5, so y equals negative 1/3 x minus 5. If my b value is negative, then I'm going to have a minus sign between x and b. If my b value is positive, then it's going to be plus, okay? All right, so that was 44. We got 48 and 50. Again, decide whether the lines are parallel, perpendicular, or neither. So look at 48, -1/2, -1/2. What kind of lines do I have? Parallel. 50, I have 4 and -2. These are going to be neither. Okay. All right. I think that should wrap us up for going over all of our homework. Questions?
The things that yes, the things that we got wrong, you want us to redo them on a different sheet of paper and turn them in?
So again, for this lesson, the new homework rules don't apply. For your own benefit, yes, make the corrections. That's the purpose of you getting the correct answers, is for you to look at what you missed. I recommend you make the corrections before you take the test, because you need to learn what you missed and why you missed it before you try to test on it. Okay.
Okay, and from now on, the new homework
Uh-huh.
that we get like this week and stuff, we use
Yes.
the new curriculum thing
We'll
for
use
that.
we'll use the new format with this coming up. So that means you'll do your homework, you'll check it, you'll identify any missed items, and then you'll make corrections. Okay.
Do you want us to do that on the chapter review?
Yes, that was part of our new homework assignment, wasn't it?
Yes.
Okay. So yes, so now that we've checked the chapter review, or you should have checked it already. So if you missed any items, make those corrections. Okay. So the chapter review will actually be your first homework assignment that you will turn in when we get back to co-op after fall break. Okay. So it'll be 2 weeks from today. When you come in, you will not only bring your test, you will bring in the chapters 3 review, the homework that we first went over, and then anything that we have from today and tomorrow. That'll
Okay.
all be what you bring on Wednesday.
Okay.
Okay.
Wait, hang on. So page 175, 176, 177, I couldn't find a place to upload those either.
Okay. All right. I'll make sure to add that date in there. Okay.
Okay,
I'll
thank you.
add that after class. All right. So we have checked all of our homework. So next week, or I guess week after next, when we start checking homework, it should go a good bit faster because we're not having to actually check any. You will have already checked them and made corrections and all that good stuff. So that leads us to our break. It is break time, and we'll come back and start with chapter 4.
Miss Jennifer,
Yes.
real quick, I thought we were starting this new format this week, so I didn't turn in my homework yet. So do you want me to turn it in after, or?
Yeah, and that's what they were saying. Actually, I'll go ahead and I'll go ahead and put the place to upload it because I had not put a date or a place for y'all to upload this homework. So I'll go ahead and do that right now,
All right,
and then you can upload it after class.
all right, thank you. And
You're
just
welcome.
175 through 177, or?
Yes, just that one, just the end for lesson 3-7. And then that'll be the last thing you have to upload besides any extra credit or whatever. So
All right, thank you.
you're welcome. Thank you.
So what do we have to upload this week?
Okay, so today's homework, let's see, today is 10/7. So I'm going to go ahead and put it on here on when I'm typing it into the what's due. And we said it was page 175 through 177, right? 177.
So
So let's see. Let me do another assignment, same thing. Except for it will be effort. Okay, so I have put the places to upload. So it just says homework 10/7, page 175 to 177. There's a place for accuracy and a place for effort. And then I have uploaded a place where it says chapters 1 and 2 extra credit. And then I think, yeah, and then I've already put a place to upload chapter 3 test. Now again, all that stuff isn't going to be due. So the only things, no, you don't have to upload the chapter 3 test. You're bringing that to class. Okay. So the only thing you have left to upload is going to be the homework, pages 175 to 177, and then the extra credit. Those will be the last things you upload. Okay. And I'll go over that again when everybody gets back, just to make sure we're all on the same page. All righty, we'll get ready to start back. So now we are going to be starting with chapter 4, congruent triangles. Okay, so again, we've talked about congruent. We know that means same size, same shape. And obviously we're talking about triangles, so we're talking about a three-sided polygon. Okay, so it shows a picture here, and it says, how does a cable-stayed bridge work? So basically, I think it's pretty neat because if we look at each of these cables coming down, we can see that we've got a bunch of triangles that are working to hold that bridge together. So anyway, so the application it's talking about, you know, the cables attaching, it allows the weight to be kind of distributed between the cables. And so anyway, we're not going to spend a ton of time talking about that, but just know that it is using the properties of congruent triangles there. Alrighty, so what's the chapter about? Congruent triangles. Congruent triangles are triangles that are the same size and same shape. In chapter 4, you will learn how to prove triangles are congruent given information about their sides and angles, and how to use congruent triangles to solve real life problems. We're going to skip over the prepare and strategies, and we're going to start with 4.1. Triangles and angles, and the first part is classifying triangles. Okay, so remember, classifying is ways of being able to describe them. Okay, so it says a triangle is a figure formed by 3 segments joining 3 non-collinear points. Okay, so my points are not collinear. A triangle can be classified by its sides and its angles, shown in the definitions below. Okay, so we know that there are 2 ways to classify triangles. 1 is the classification of sides. 2 is by angles. So if we look at the sides, the first one is an equilateral triangle because I have 3 congruent or 3 equal sides, and that is indicated by those little dash marks. Okay, if I have the same number of dashes, then that means they are equal. So since there's 1 dash on each side, equilateral. The next one is isosceles triangles, and isosceles triangles have 2 congruent sides. So we can see that these 2 sides are congruent, and then we have a third side that is a different measure. Okay, so 2 congruent sides. So we've gone from 3 congruent to 2 congruent. So now my scaling, no congruent sides. They're all different measures. Okay, so you need to know equilateral triangles, isosceles triangles, scalene triangles. 3 congruent sides, 2 congruent sides, no congruent sides. So that's naming them by their sides. Now we're going to look at naming them or classifying them by their angles. Okay, so the first one is an acute triangle. So remember, we know that the word acute, when we talk about acute angles, it means that they are less than 90 degrees. Okay, so I know that they are less than 90 degrees. So that means that all 3 of the angles in an acute angle are less than 90 degrees. So all 3 angles are less than, nope, wrong direction, go back, less than 90 degrees. Okay, equilateral, equiangular. This is kind of a funny word, but equi means equal, angular, talking about angles. Equiangular triangles means that I have 3 congruent angles. So again, now instead of the side marks that we saw earlier, I've got my angle marks that show that each angle is going to be the same. So 3 congruent angles are called equiangular because we were talking about the angles. Earlier, equilateral, lateral means sides. Okay, so equilateral, that's all for my football friends. When you throw a lateral pass, where is it going? Side to side, right? So a lateral means it's just going to the side. So when you think about equilateral, we're talking about the sides of the triangle. Equiangular, we're talking about the angles in the triangle. And then finally, a right angle means that I have got 1 right angle. Okay, now remember, I can only have 1 right angle in a triangle because the angles, and we're going to talk about in a little bit, the interior angles add up to equal 180 degrees. So if I had more than 1 right angle, I've got 90 plus 90, that's 180. I couldn't have any other angles. And I know at the triangle, I have to have 3 angles. So I can only have 1 right angle in a triangle. Okay, so we have acute triangles, we have equiangular triangles, we have right triangles, and then finally an obtuse triangle. Again, I can only have 1 obtuse angle because if I had more than 1, I'm going to end up equaling more than 180 degrees, and the interior of a triangle cannot be greater than 180 degrees. So you can either have 1 right angle, 1 obtuse, but that is it. All right, so example 1, it says when you classify a triangle, you need to be as specific as possible. So letter A says triangle ABC, and you can see the way that they named this is just using the little triangle symbol. So triangle ABC has 3 acute angles and non-congruent sides. So I know that my angles are all going to be less than 90 degrees. Okay, so less than 90 degrees, but no congruent sides, which means none of my sides are the same measurement. It is an acute scalene triangle. So what we've got to do is we've got to look at these where if I had no congruent sides, but they're all acute. So we call that acute scalene. I'm having to name it by its sides and by its angles. The next one, B, I have triangle DEF has one obtuse angle. So again, one obtuse angle tells me it's an obtuse triangle. Two congruent sides tells me isosceles. So it is an obtuse isosceles triangle. Name it by the sides, name it by the angles. Any questions about that? All righty. Each of the 3 points joining the sides of a triangle is called a vertex. So here's a vertex, here's a vertex, here's a vertex. When you're talking about the plural of vertex, the word is vertices, okay? So one is a vertex, more than one, you call them vertices. So you can see that A, B, and C are vertices. In a triangle, 2 sides sharing a common vertex, so common vertex, 2 sides sharing a common vertex are adjacent sides. So here I would have this side and this side would be adjacent because they share point C, or I could have BC, whoops, let me go back to I could have this side and this side are adjacent because they share a common vertex. Or I could have this side and this side, okay? So if they share a common vertex, they are adjacent sides. And then in angle ABC, CA and BA are adjacent sides, and the third side, BC, would be called the opposite of angle A, okay? So when I talk about, if something talks about the opposite of angle A, what I look at first is I say, okay, angle A, I find the point, and this is the angle. This direction is the opposite of that. So when I'm locating the opposite of something, so if I'm talking about point A, I can see that these are my adjacent sides that share point A, and I can see that the opposite side is going to be BC. Now again, all of that would change if I was talking about angle B or angle C. I would have different adjacent sides and different opposite sides based on which angle I'm looking at. Okay, so I've got to pay attention to which angle it's telling me to work from. Right and isosceles triangles. The sides of right angles and isosceles triangles have special names. In a right triangle, the sides that form the right angles are the legs of the right angle. The side opposite the right angle is the hypotenuse of the triangle. Okay, so like I said, here we are talking about right and isosceles triangles. So the first one is our right triangle, and we talked about how a right triangle has one right angle. Okay, so the first thing I've got to do is identify the placement of that right angle. The sides that are adjacent to the right angle, right there, are going to be what we call our legs. And again, I look at my angle and I go opposite to determine my hypotenuse. So the hypotenuse is always opposite the right angle. Okay? Another thing to know about the hypotenuse is always going to be the longest side of your triangle. All right? But if I was talking about an isosceles triangle, we say that the base is going to be the side that is not the same length, okay? So our legs are going to be the sides that are the same or congruent lengths. And then we call the base the side that is not the same measure, okay? So in all of these, we're going to have legs, but one we'll call the hypotenuse, one we'll call the base, depending on what type of triangle it is. So example 2 says identifying parts of an isosceles right triangle. So again, here I've got my triangle, and we can see that right here is what we're talking about. I can see I've got that right angle identified by the box. So that means that I've got two sides that are going to be my legs. Okay, I have a leg here and a leg here. Make those yellow. And then directly across from it is going to be my hypotenuse. Is going to be across from the right angle. So again, it's always good before you start looking at things to go ahead and break the diagram down. Look at what you know from the diagram, and then if there's something that you're not sure about, then you kind of start investigating. But look at the diagram first, say, okay, I know I've got a right angle here, so I know I'm talking about a right triangle. I know based on this drawing that each side is 5 feet. Okay, so I can see that those sides are congruent because they have the same measure. And then I know that the hypotenuse is directly opposite of the right angle. Therefore, that's going to be my longest side. And they've told us that that side is 7 feet. Okay, so it says explain why triangle ABC is an isosceles right triangle. So the first thing is we know we've got a right angle. Okay, so we have a right angle. And then the second thing is that we know that we have two sides that are congruent because they have the same measure, okay? So we know that AC is 5 feet. We know that BC is 5 feet. So we know that those are two congruent sides. So we have one right angle and two congruent sides, therefore it's an isosceles right triangle. Now it says identify the legs and the hypotenuse of triangle ABC. Okay, so we did that in the beginning. We said we know that the sides that are equal to each other are going to be my congruent sides. And so here it says sides AC and BC are adjacent to the right angle, so they're the legs. Side AB is opposite the right angle, so it is the hypotenuse. So it says because AC is congruent to BC, then AB is also the base. So again, leg, leg. We can call this the hypotenuse or the base. Okay. Sorry, not the hypotenuse because, yeah. So really either one, since it's a right angle, you could call it the hypotenuse or the base. Okay, any questions about those? Any questions about identifying the things that we've just talked about with legs?
I think that this is easy.
Good, good, good. I think triangles can be something that's a little more enjoyable because it's more concrete. Okay, we're able to look at these, we're able to give it a name, we're able to compare them, and so it is hopefully a little bit more easy. All right, goal 2 is using the angle measures of triangles. So basically when we're talking about the angle measures, we can see here that we have interior angles and we have exterior angles, okay? So it says there are 3 interior angles, and that's what we're talking about here with A, B, and C. That's the shaded parts here. Interior, they're going to be inside the triangle. Exterior are going to be these angles that are outside, that are formed on the outside, okay? So we have interior angles and exterior angles. And it says each vertex has a pair of congruent exterior angles. It is common to show only one exterior angle at each vertex. Okay, so it's not like I would have to keep going that way and show another exterior angle and keep going this way and show another one, you know, stuff like that. So we don't have to worry about that. It's just common to show the one exterior angle. Okay, but exterior would be if those sides continued on and I looked at what would be on the outside. Now, real quick, I want to do something. I'm going to back up for a second. You don't have to flip back unless you just want to. If you go back to, where did I have that? Why is it not in your book? Real quick, I'm going to take a picture of something that's in my book that I wanted to show you that I thought was pretty interesting. And basically what I'll do is I'll just kind of zoom in and take a picture of that. All right, so now I'm going to send it to myself. I've got my windows open and there's a birdie out front. I don't know if y'all can hear that or not. Let's see. It's fussing about something. Come on. No. Not wanting to load the. There it is. Okay, so in my book, what it did is it showed, like, if we've got the interior angles like we just talked about, how we know whether we're talking about the inside part. If I were to take those interior angles out and put them together on a line, you can see that when those interior angles would join, they would add together to make 180 degrees. Okay, so those interior angles would come out. You could put them together and they would add up to make 180 degrees. And the same thing with my exterior angles. When I have exterior A, B, and C, if I were to take the exterior angles of them and again put them together, I would add up to make a straight line, which is 180 degrees. So that is why when we talk about the interior and exterior angles add together to make 180 degrees, this is why, okay? Because if I actually were to remove them from the triangle and put them together, when I laid them out, it would make that 180 degree measure, which is equal to a straight line. Okay, so again, it's the kind of thing where a lot of things in geometry are kind of abstract. So whenever we can kind of get a concrete visual, I get excited about that because we can kind of see that and understand it a little bit more instead of just saying, well, it's just a rule and that's just the way it is. I hate doing that in math, saying, well, why is it this way? Well, just because, just memorize it, just learn it. I want you to know the whys behind it. Okay, so I thought, like I said, I thought that was a good visual because we always hear that, hey, they equal 180 degrees. Why? Because if I were to take those angles apart and put them together, they would form the arc for a straight line. All right, so let me go back. Okay. I don't know why they would have put that in my book and not yours, because I thought it was a great visual for you guys to have. All righty, so like we just talked about, our interior angles, this is our triangle sum theorem that we have here. And it says the sum of the measures of the interior angles is 180 degrees. So when I add A plus B plus C, 180 degrees. So that is my triangle sum theorem. Again, chapter 4 folder, blue folder, this would be something to put in there in addition to the things that you should have already, interior angles, exterior angles, the types of triangles, things like that. To prove some theorems, you may need to add a line or a segment or a ray to the given diagram, and this is called an auxiliary line. So sometimes we have to give an auxiliary line to be able to prove something. So you can see here we've got the triangle ABC, but they went ahead and added an auxiliary line here. Okay, now let's look at this before we even talk about it. If we add this auxiliary line here, notice we've got these little arrows. So what does that mean about line BD and AC? That means they're parallel. Okay, so we've added a parallel line. BD is parallel to AC, and I know that based on these little blue arrows that they've put on there. Okay, so now I have not only been able to identify my interior angles as 1, 2, and 3. By adding that auxiliary line, I've been able to do exterior angles 4 and 5. Okay. So looking at that diagram, that's what all of that means. So let's look over here. So it says, given triangle ABC, you've got to prove that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180 degrees. And it says our plan for the proof is by using the parallel postulate. You can draw an auxiliary line through point B and parallel to AC. Because angle 4, angle 2, and angle 5 form a straight angle, the sum of their measures is 180 degrees. You also know that angle 1 is congruent to 4 and 3 is congruent to 5 by the alternate interior angles theorem. Okay, so now we're able to pull in these other theorems that we've pulled from previous sections and previous chapters. So alternate interior we're able to use based on chapter 3. So you can see that the first thing they said is draw BD parallel to AC, and that's using the parallel postulate. 4, 2, and 5 add together to make 180. That's the angle addition postulate and definition of a straight angle. Angle 1 is congruent to 4. Angle 3 is congruent to 5. That's our alternate interior angles theorem. So if 1 equals 4 and 3 equals 5, that's from our definition of congruent angles. So that means I can add 1, 2, and 3 to equal 180 degrees by substituting, because I have substituted angle 2 for 4 and angle 5. What did I just say? Definition of congruent angle, substitution property of equality. So I have been able to substitute those. Millie, come here. All right, and then our next theorem is the exterior angle theorem. So again, the measure of an exterior angle of a triangle is equal to the sum of the measures of the two non-adjacent interior angles. Okay, so let's think about this for a minute. The measure of angle 1, okay, is equal to the measure of A and B. So I have this one exterior angle out here. Remember, exterior is going to be on the outside. So I know that that angle is equal to adding angle B and angle A together. Okay. So this is called the exterior angle theorem. An exterior angle is equal to the sum of the two interior angles that are not adjacent to that exterior angle. So to kind of look at that a little bit better with numbers, we have example 3. And so they've shown us that here is our exterior angle, 2x plus 10. They've shown us that our interior angles are going to be 65 and x degrees. We just learned from this theorem that I can add those two interior angles together to equal the exterior angle. So that's what we've done here, is we have our two interior angles to add it together to equal the exterior angle. So x plus 65 equals 2x plus 10. So in this situation, subtract x. So 65 is equal to x plus 10, subtract 10, subtract 10. So 55 equals x, or x equals 55. Okay, so remember, when I have that exterior angle, that is equal to the sum of the two interior non-adjacent. Questions about that? Okay, this is one of those that you just have to memorize. All right, there's really not a trick to remembering it. It's just to memorize that. And it says the corollary to a theorem, okay, so we've got a new word, corollary, is a statement that can be proved easily using the theorem. So the corollary below follows the triangle sum theorem. So this is the corollary to the triangle sum theorem, and it just says that the acute angles of a right triangle are complementary. So angle A is the measure of angle A plus the measure of angle B equals 90 degrees because I know that this angle is 90 degrees, right? So if I have the sum of my angles is 180 and I subtract 90 from that, I know that I've got 90 left to split between A and B. So that means if I add A and B together, that equals 90 degrees. So that is if I have a right triangle. In a right triangle, the acute angles are complementary, which means they add together to make 90 degrees. Example 4, finding angle measures. The measure of one acute angle of a right triangle is 2 times the measure of the other angle. Okay. The measure of one acute angle of a right triangle is 2 times the measure of the other angle. So when I'm dealing with my right triangle, I know that I've got one that is 90 degrees. Then I know my smaller one is going to be what we can call X, and my third angle that is not the right angle and is not the smaller angle will be 2 times that number. So we've got the sketch. So we've got the right angle. We've labeled our smaller angle X degrees. Our larger one is 2X degrees. So basically we know that if we add X and 2X, that is going to be 3X. So we have 3X is equal to 90. Divide by 3, divide by 3. So X is equal to 30. If X is equal to 30, then I know that this is 30 degrees here. So if this is 30 degrees, that means this one over here is 60 degrees because it's 2 times X. I plug in 30 for X, and 2 times 30 is 60. Any questions on that? All right, so let's look through our practice here. The first one says sketch an obtuse scalene triangle, label its interior angles as 1, 2, and 3, and draw its exterior angles, and then shade the exterior angles. So we'll go ahead and do that as a group. So let's go ahead and, okay, so it said to sketch an obtuse scalene triangle. So let's think about that for a minute. Obtuse means I'm going to have one obtuse angle. Okay, so I'm going to have one obtuse, 2 acute, and then scalene. What is scalene? Tell me about the sides. That none of them are what? None of them are equal, right? So they're all different lengths. So I'm not really going to measure I'm not going to worry too much about it. So basically I'm just going to do something, or actually let's make it stand up a little more. Something like that. Okay, let me do better. There we go. Okay, so if this is my obtuse scalene triangle, I'm going to have angle 1, angle 2, and angle 3. Okay, so obtuse scalene, I've labeled it 1, 2, and 3, and then it says draw its exterior angles. So now what I'm going to do to draw my exterior angles, I'll change my color for this. That means basically I'm just bringing out my line a little bit from each side. Okay, so I know when I bring my line out, I've got this angle here, I've got this angle here, and then I've got this angle here. Okay, because I know when I bring this line out here, the other side is going to be 180 degrees. So basically I'm shading the side that is not the 180 degrees. Okay. Questions on how to identify interior and exterior angles? All right. The next section says in the figure, I have side PQ is congruent to side PS. So we see that that is labeled with our little lines. PR is perpendicular to QS. Okay, so we can see where PR and QS intersect at a right angle. So it says complete the sentence. PQ is the blank of the right triangle, triangle PQR. So PQ, okay, so if I'm talking about this line right here, PQ is the blank of the right triangle PQR. So I'm talking about this triangle here and PQR. What do I know right here? If the other side's a right triangle, I know that one's a right triangle. So what is PQ going to be?
The hypotenuse.
Okay, hypotenuse, good. So that is going to be my hypotenuse. Okay. Number 3, in triangle PQR, PQ is the side opposite of angle what? PQ is the opposite of which angle?
PS.
Okay, so look at, if we're talking about this side right here, okay, and we're talking about opposite, remember that means,
Oh, R.
okay, so we could either call it angle R or we could call it angle PQR. Okay, so we would have PQR, so we could have angle PQR. We could call that angle QRP, or we could just call it, actually we could not call it angle R. Why? Anybody know why we could not call it angle R? Any guesses?
It's not an angle.
Well, right here, it would be an angle, but notice it's shared with this triangle over here. So if I just call it angle R, I don't know if I'm talking about this angle here or this angle here. Because there's 2 possible things that could be naming, I don't want to name it by just a single angle. I need to name it by 3 letters that make that angle. Okay, so I could either go QRP or PQR, either way. But I wouldn't want to name it just by a single letter because it could mean either triangle. Number 4, QS is the blank of the isosceles triangle, triangle PQS. Okay, so let me erase a little bit so we can kind of see a little more clearly.
Is it the base?
It is the base, good. So QS, we're talking about here. So notice really in this figure, how many triangles are we talking about? How many total triangles do we have here? I could have this triangle as 1, this one is 2, and then this whole triangle would be triangle 3. So really in this diagram, I've got 3 different triangles that I can discuss. So that's what we're talking about here with this base of QS, because when I'm talking about QS, I'm talking about the entire triangle of PQ, let me do a different, I'm talking about PQS. I'm talking about the entire triangle. All right, so we said that that was the base. All right, number 5, the legs of triangle PRS. So first of all, I want to identify the triangle I'm talking about. So I'm talking about triangle PRS. I'm talking about this triangle over here. And it wants to know the legs.
PR
Okay.
and SR?
All right, so we know that the legs are going to be the sides that are adjacent to the right angle. So I know I've got PR is going to be 1. So PR, and then RS or SR, either way. So, so then that means that PS, again, is our hypotenuse. So does everybody feel pretty comfortable identifying and knowing legs and angles and hypotenuse and all that good stuff? Okay, so numbers 6 through 8 says classify the triangle by its angles and by its sides. So here, I know that I've got sides, 2 sides congruent. So what did we say if they're 2 sides congruent? What is it called?
Isosceles.
Isosceles, ISOSCELES. So I know I've got isosceles. And then what do I know about each of the angles? They're all what? Do I have any 90-degree angles, or are they all less than 90 degrees? I don't have an obtuse. I don't have a right angle, so they're all acute. So I have an acute isosceles triangle. Remember, I have to name it by the angles and by the sides. Number 7. I see that red box there, so immediately I know I'm dealing with a right triangle. And then I look to see, hey, are any of my sides equal? I don't have any of those little hash marks to tell me that they are equal, so I know that when I have no equal sides, that's called scalene. So I've got a right scalene triangle here. And then the last one, I can see that all of my sides are congruent and all of my angles are congruent. Okay.
Equilateral.
Okay, so this one's going to be kind of a mouthful. When we talk about our sides being equal, that is equilateral. What do we call it when all of our angles are equal? So this is an equiangular equilateral. Equiangular means all of my angles are equal. Equilateral means all my sides are equal. So I could call this equiangular equilateral. All righty. So our assignment for this section, it's almost time to wrap it up. So we will have our assignment, which will start on page 198 and will end on page 200. So 198 to 200. We are going to do numbers 11 through 47 odds. 11 through 47 odds. Okay, so remember, make notes at the top of your homework page. Go ahead and label it. It'll be lesson 4.1. You'll go ahead and write some notes to yourself. You can, you don't have to, if you want to draw figures in your notes, you're welcome to draw figures. If you just want to write just some quick, even if it's, you don't even have to really write the definition of like a right triangle. You can just write the different types. You can write, if I'm looking back at my triangles that we had up here, I can just make myself a note that says, classification by sides, equilateral, isosceles, scalene. Classification by angles, acute, equiangular, right, obtuse. Okay, so then that way, that would cover this section. I don't have to draw pictures unless I want to. I don't have to write definitions unless I want to. The main thing is just where you're hitting the highlights and saying, okay, I know I'm dealing with this. And then going in again, vertex, adjacent sides, hypotenuse, legs, things like that. If however you want to write those notes in there, interior angles, exterior angles. Triangle sum theorem, you're going to want to have on there. Exterior angle theorem, you're going to want to have on there. The corollary to the triangle sum theorem. And then that's it. So those will be kind of the points that you're going to hit at the top in your notes. Whether it's just even one word or the title of it, if you don't want to write the definition, as long as you know what they mean, that's one thing. But if you don't know what it means, don't just write, corollary to the triangle sum theorem, okay? You might want to write right angle of a right triangle is complementary, or the acute angles of a right triangle are complementary. Go ahead and make that note there if you don't already know what it means, okay? Then for 11 through 47, again, notice that on 11, 13, and 15, okay, all you're going to be doing is you'll write out, so like on 11, you'll write side lengths, 3 centimeters, 2 centimeters, and 3 centimeters. But when you write your answer, you're just writing a letter. You can write the letter and the word, or just the letter. It's up to you, okay? So, but just be sure to write the problem. When you have drawing a diagram, if you want to be able to mark up your diagram, you can draw the diagram to help you mark it up. it's up to you. Okay. But anyway, I know that writing out the problem and everything is going to be a little different in geometry than it is in algebra. In algebra, you've got, you've got a set problem that you're writing out. And in geometry, you've got pictures and diagrams and things that you can write as well. Alrighty, so there's our homework, page 198 to 200, 11 through 47 odds, and we will have the chapter 3 test. Okay, I will be emailing that to you guys. We have gone through the chapter 3 review. We have walked back through the chapter. If you want to do it again before you take the test, go for it. Okay, so when I see you guys tomorrow, we'll kind of go back over this, make sure we're clear on everything. If you if you work on the homework tonight and have any questions, you can let me know tomorrow. Sorry, I'm going over our time. I will get ready and let you go. If you have questions, let me know. If not,
Bye.
I will see you guys in the morning.
Bye,
Bye.
Jennifer.
Bye, guys.
Thank you.
You're welcome. Thank you.
Bye. Thank you.
Bye, Keely. Thank you, hon. Bye, Lucas. See you tomorrow.